Learning objectives. At the end of this topic, you will be able to learn tests for divisibility of numbers 2, 3, 4, 5, 6, 9, 10 and 11. Find the common factors and common multiples of a given set of numbers. Understand prime factorization for a given composite number.
Tests of divisibility rules. We have some shortcut rules to find whether the given number is divisible by 2, 3, 4, 5, 6, 8, 9, 10 and 11 without actual division. Let us start from divisibility by 2. A number is divisible by 2 if it has any of the digits 0, 2, 4, 6 or 8 in its ones place. For example, we take a number 246. The last digit of this number is 6. Therefore, this whole number 246 is divisible by 2. Consider the other number 314. The last digit is 4. Therefore, 314 is divisible by 2. Test of divisibility by 5.
A number which has either 0 or 5 in its ones place is divisible by 5.
For example, consider the number 425. The last digit is 5. Therefore, this number is divisible by 5. Consider another number, 850. The last digit is 0. Therefore, 850 is divisible by 5. Divisibility rule for 4. If the last two digits of a number is divisible by 4, then the whole number is divisible by 4. Let's see a few examples for divisibility by 4. Example 1. Consider the number 2444. The last two digits of the number is 44. It is divisible by 4. Therefore, 2444 is divisible by 4. The next example is 3128. The last two digits is 28. It is divisible by 4. Therefore, 3128 is divisible by 4.
Divisibility rule for 8.
A number with 4 or more digits is divisible by 8 if the number formed by the last three digits is divisible by 8. Example. Let's consider the number 73,512. The last three digits of the number is 512. It is divisible by 8. Therefore, 73,512 is divisible by 8. Next example. Consider the number 85,104. The last three digits, 104, is divisible by 8. Therefore, 85,104 is divisible by 8. Divisibility rule by 10.
If a number has 0 in the ones place, then it's divisible by 10.
Example. Consider the number 340. The last digit is 0. Therefore, 340 is divisible by 10. Consider another example. 5,570. The last digit is 0. Therefore, 5,570 is divisible by 10. Divisibility rule for 3. If the sum of the digits is a multiple of 3, then the number is divisible by 3. Example 1. Let's consider the number 225. The sum of the digits of this number is 2 plus 2 plus 5 is equal to 9, which is a multiple of 3. Therefore, 225 is divisible by 3. Let's see another example. 552. The sum of the digits of this number is 5 plus 5 plus 2 is equal to 12, which is a multiple of 3. Therefore, it's divisible by 3. Divisibility rule for 9. If the sum of the digits of a number is divisible by 9, then the number itself is divisible by 9. Example. 5,634. The sum of the digits of this number is 5 plus 6 plus 3 plus 4 is equal to 18, which is divisible by 9. Therefore, 5,634 can be divided by 9. Consider the number 8,12,439. The sum of the digits of this number, 8 plus 1 plus 2 plus 4 plus 3 plus 9 is equal to 27, which is divisible by 9. Therefore, 12,439 is divisible by 9. Divisibility rule for 11. Find the difference between the sum of the digits in the odd place from the right and the sum of the digits in the even place from the right of the number. If the difference is either 0 or divisible by 11, then the number is divisible by 11. Example, let's consider the number 1331. The sum of the digits in the odd place is 1 plus 3 is equal to 4. Sum of the digits in the even place is 3 plus 1 equal to 4. The difference is 0. Therefore, 1331 can be divided by 11. Let us consider another number. 61,809. The sum of the digits in the odd place is 9 plus 8 plus 6 is equal to 23. The sum of the digits in the even place is 0 plus 1 equal to 1. The difference is 23 minus 1, which is equal to 22, which is a multiple of 11. Therefore, 61,809 can be divided by 11. Hello friends! Here let me explain to you about common factors and common multiples. Factors which are common to the given set of numbers are known as common factors. Let me solve a few examples here. Find the common factors for 8, 12, and 16. The factors of 8 are 1, 2, 4, and 8. The factors of 12 are 1, 2, 3, 4, 6, and 12. The factors of 16 are 1, 2, 4, 8, and 16. Here, 1, 2, and 4 are the common factors for the given numbers. Hence, the common factors of 8, 12, and 16 are 1, 2, and 4. Common multiples. Multiples which are common to a given set of numbers are known as common multiples. Find the common multiples of 4, 6, and 8. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, etc. The multiples of 6 are 6, 12, 18, 24, 36, 42, 48, 54, 60, etc. The multiples of 8 are 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, etc. Therefore, the common multiples of 4, 6, 8 are 24 and 48. Here, 24 and 48 are the common multiples for the given numbers. Prime factorization. The method of expressing a given number as a product of prime numbers is known as prime factorization. We have two methods to find prime factorization. They are factor tree method and division method. Factor tree method. Take the number 90. 90 can be written as 9 times 10. 9 can also be written as 3 times 3. Similarly, 10 can be written as 5 times 2. Hence, the prime factorization of 90 is equal to 3 times 3 times 5 times 2. Next, let me explain the division method. Consider the number 48. We have to split the number as a product of prime numbers. 48 can be divided by 2 by 24 times. 24 can be divided by 2 by 12 times. 12 can be divided by 2 by 6 times. 6 can be divided by 2 by 3 times. Hence, the prime factorization of 48 is equal to 2 times 2 times 2 times 2 times 2 times 3.
Summary. Let's summarize the topic. We have discussed how we can just find by looking at a number whether it is divisible by small numbers 2, 3, 4, 5, 8, 9, and 11. We have explored the relationship between digits of the numbers and their divisibility by different numbers. Divisibility by 2, 5, and 10 can be seen by just the last digit. Divisibility by 3 and 9 is checked by finding the sum of all digits. Divisibility by 4 and 8 is checked by the last 2 and 3 digits, respectively. Divisibility of 11 is checked by comparing the sum of digits at odd and even places. We have discussed about the common factors and common multiples. We've learnt about prime factorization of a given composite number. We learnt the factor tree method and the division method to find prime factorization.